I'm Peacock Tobler.
And I'm Sean Peacock.
And we're presenting our final project for microcontrollers.
So for our final project, we decided to make a laser tag module that we can use on a RC car so that we can drive around and play laser tag with these RC cars. It'll be fun for anyone.
Exactly. So how we have designed it is that there's a wireless remote that connects to a wireless receiver. On the wireless remote, there are options to turn a turret and an option to fire an IR transmitter. And then on the receiver side, we'll have the IR sensor that will detect whether or not it has been hit by the beam of an IR transmitter.
Let's go take a look at the details. Alright, so diving into the details, we decided to include a few libraries to help us with the Wi-Fi module setup, and we also set up our pins in this manner. Our buttons did need to be active low, so we decided to start by setting them all to high.
Exactly. So then we gave to our sender the receiver address, and we set up a struct to carry the data. Then we initialized the Wi-Fi modules, which is all that's happening here. And finally, we set up our pins to be input pull-up so they could be buttons.
Finally, in our loop, we read in each one of the pins and use a series of if statements to determine what will happen. We decided to send a state variable, as Michaela mentioned. This variable, mydata.b, will send either a 0, 1, or 2, depending on which button is pressed, to the turret controller. And if no buttons are pressed, then a 3 will be sent, which is our standby phase.
Alright, so this is the receiver code. We start by declaring our pins and also setting up a struct that matches the sender struct. Then we're declaring that struct, and then what happens when the receiver gets a message is that it copies the sending struct into the received struct. And then we have an interrupt that simply assigns a boolean to true if it senses that it's been hit.
We then go on to our setup function. In our setup function, we basically just set up the receiver of the Wi-Fi module side, and we set up the outputs and inputs of all the pins that we need for our microcontroller. We then move on to the loop.
So in the loop, there's 3 basic things that we do. We execute a turn if there's a turn, we fire the, the transmitter if there's a fire, and we check to see if it's been hit.
Then we move on to the turn clockwise or counterclockwise function. That's all it does, is it turns it either clockwise or counterclockwise depending on inputs we get from a Boolean variable.
And so then the turn checks that state variable that the sender module sent to it, and then sends the appropriate Boolean into the turn function.
Finally, we have our fire function. In the fire function, we basically get our state variable from the sender module, and then all we do is we send a wave at 20 pulses at 38 kilohertz.
Okay, so this is the explanation of the wiring of our project. First, we have our microcontroller, which has a Wi-Fi module on it. It's connected via USB to our power source. And then we have 3 buttons. That'll be simple. This will be our left turn or counterclockwise. This will be our right turn or clockwise, and this will be our fire. Then over here on the receiver side, we likewise have a matching microcontroller, and then these are the 4 motor pins which connect to the motor driver over here. We're also connected to power via these 2 pins, just the simple 5-volt output power. And then we can see that when I press the counterclockwise button, it begins to move counterclockwise. And when I press the clockwise button, it will move clockwise.
Yes. Moving on to the fire part of our project, you can see that we have the transistor right here that helps control. It acts as a switch in this case, as a control for our IR transmitter. This will help, as we saw in the code, to send this at a 38 kilohertz wave. Then what this will do, it will send the signal to a receptor like this on a different tank that will take in the 38 kilohertz wave, and it will light up this red LED to signal that it has been hit, and it will disable our controller for about 5 seconds. To demonstrate this, we'll actually just have the IR receiver shoot itself so you can demonstrate. So Michaela will press the red button to fire, and it should shoot the controller. So it is disabled. You can't turn it or anything until it goes back on. And that is how our microcontroller boards are working. All right, so for the final part of our project, we decided to mount it in this way. Obviously not perfectly ideal, but it does work pretty well. So kind of the two components we haven't really talked about are the power supply itself. Right here, we used an external just power bank to power this entire part of the module. And then we also have the tank turret head. So up here, we inserted the IR sensor into a small hole in the inside of this 3D printed tank head. And with that, we just set this a little hole right here to set on the motor. And that is what turns the tank head.
Okay, this is our remote module. We attached it to the actual remote for the car, and then our power is again coming from the computer, and these are the simple commands and the fire button.
All right, for the final part of our project, we wanted to demonstrate actually our cars in use. So me and Michaela, we got our controllers ready, and we're going to have a little take-off battle right here in front of us. We'll turn to the tanks. Oh, let's turn it. Oh, hit! That's a win. Victory dance, run away.
Can't move, can't move.
All right, she's free again. We can go back and try to shoot her. Now that I got closer to the angle, we'll try to give her a good shot. Might need to get a little closer. I don't know. Oh, got her again. One thing that we did notice while playing with these is that you do have to be pretty darn accurate at hitting that sensor.
It's true. So something that we could do in the future to make it better is put a little larger array of sensors there, or put a lens into the tank barrel so that we could just make it easier to hit the target. Oh my gosh, you just keep hitting me. The fence is small. I can't move my turret. So late and I can't break it. Come on now. Go there.
Ah, she got me. All right, thanks for watching. Please like and subscribe in the links below. Thank you so much for coming. Have a great day.